Testing, testing. Hopefully some people can hear this. Okay, we'll start in a couple of minutes. Someone's asking, can I explain how the Lexer works? Not really. I mean, it's very simple. Hello, everybody. Welcome back. In the previous stream, we discovered that maybe I'm not going to change the way polymorphism worked fundamentally. And maybe we're going to keep the name moving version that we have now. In fact, maybe that's absolutely necessary to the functionality. And that seems true to me. So given that that's the case, then what I should do is stop kicking the can down the road on robustness of certain things that I suspect don't work and haven't ever really tried. So what I'm going to do now is put together some trouble cases for especially the autopoly part of polymorphism. I think that's the one that's really maybe not necessarily going to work. And fix those so that I don't have to wait for them to show up to me in a bug report. And then after that, I don't know, like we'll just play around. I want to keep simplifying things. That's the mood that I'm in, is to find things to simplify. So either we'll come up with some idea for what to do, or maybe I'll search for cleanups. I don't know. How's my break? I'm pretty tired today because I've been streaming 3 days straight. Streaming programming is pretty rough for me. Maybe if I did it, maybe if I was a full-time streamer, I would just be able to do it. But I get tired. Okay. Yeah, I mean, something like a Lexer, I just don't consider complicated enough to be worth talking about. Which I know is frustrating if you're beginning and you don't know how any of that stuff works. But of course, if you go see some random person's Lexer advice, it might be bad advice. So maybe I should someday talk about it. I don't know. Anyway, let's go back to our test file, which we started expanding out into all this random stuff. We're going to contract it back. And I want to do some autopoly situations. So we're just going to delete all this stuff. And, well, let's start with Hello Sailor. That's always a good place to start. I'm in the wrong shell. Being in the wrong shell, in the right shell is good. Okay, so we're at Hello Sailor. That's great. Now, I want to make a thing called Foozle. And yeah, this is a polymorphic struct that takes 2 parameters. So I'm going to say fooz is a foozle of int and float. Let's call it fooz1. Okay, see what happens there. You know, we're not anywhere crazy yet. So this is a struct that takes, you know, an int and a float. And then we'll do another one. Fooz2 is a foozle of string and type of fooz1. Let's try that. So that's a little hairier. I think that this should work. There you go. So that is pretty good. That's a pretty powerful programming language right there, right? You know, we ain't doing too bad. But now, so let's do some autopoly things. So, well, let's do a non-autopoly. So we say non-auto is a procedure that takes a foozle called f, but it's a foozle of $A, $B, right? And a prefix string. I just want a non-polymorphic parameter. In fact, let's put the prefix first because it's a prefix. Okay, and we'll say print A is, comma, A. Prefix A is A. Prefix, comma, A. B is something, B. Okay. So let's see that even compiles, right? And test, we're not calling it yet, so we're not doing anything yet. So now we'll say non-auto of sailor, comma, well, I can pass any foozle here, right? So I can go foos1, and I can go foos2. This is hello, and that's sailor, all right? So test. Okay, hello, A is S64, B is float32, F is foozle, right? A is string, B is some polymorph of foozle, F is that. So this is all working great. Will it be used to make game engine or games directly using the language? Well, to make a game, you kind of have to make an engine, so it's both. Okay. So now we're going to go yes auto, and it's the same thing except we're getting rid of the A and B. This should work too because, I mean, unless I screwed something up real bad, we're still in the realm of things that should work. Uh-oh. Undeclared identifier A. Maybe this only works if it's a pointer, which would be weird, but I wouldn't be too surprised. So if that only works if it's a pointer, then it's our first thing that maybe I should put on the list to fix. Oh, we don't have, okay, sorry, no, that's not the problem. The problem is because these are automatic, we don't have an A or B anymore. This is just a regular undeclared identifier. So we need to say type of f.a. Or we could say, forget it, we could say f.sum a. We can do it both ways, right? So we could say f.sum b here, but we're going to say type of f.b, right? So, oh, now I left my pointer in there. Okay, great. I want to change my prefixes here. Hello, sailor, frauts, and resrav are the new prefixes. Just so we can be clear what we're looking at. Okay, so, well, it should be the same as before, and it is, right? So what this is that auto-poly stuff that I was talking about before where you could say foozle just like you would in a dynamic language, but it's really a static thing, right? And you don't have to declare this procedure as a template like you would in C++, but it is, or D or anything like that. But this essentially is what you would think of in those languages as a template function, right? So we desugar this to this, or, you know, with some arbitrary names made up, and then we go forth from there, right? Does all this make sense? This is like how the language has worked for a long time, but we're going to keep pushing it until it breaks because I'm pretty sure how to break it. So let's make a yes auto 2. And this is going to take 2 foozles. And we'll start doing something different. We'll say if f.sum a is equal to g.sum a, print a matches, else print a doesn't match. Okay, so now A and B don't match for either of these. So how about yes auto 2 of, I don't remember my spell names anymore, Nusto, and foo1 and foo2. So neither of these should match, but the procedure should work, except of course, I probably screwed something. Oh, we have a crash. Oh, well, this is the thing, right? So we have two autopolys now. We certainly shouldn't crash. I have to fix that. But we have two autopolys, and when you have an autopoly, it makes a variable name, but it's making the same variable names for both of them, right? And then we're trying to bind those into the constants block, and that doesn't work yet. And I always knew that didn't work, but I was like, I'm going to change this later. But it's later, and we haven't changed it, so it has to work. So we actually have two problems, right? We have one problem that we're hitting this error at all, and we have problem number two that we're crashing after the error. Crashing after the error is probably easy to fix, so let's do that. It's probably like someone is assuming that something's not null. Isn't it a bit disturbing that a procedure is magically polymorphic with no explicit markers like $t/fusel? Well, maybe, except that if you used your syntax highlighter in your editor for something good instead of all this useless fruit salad that everybody does, then you could know that, right? Like the procedure would just be boldface or thin, unboldface, right? Like lightface. And then you'd be like, oh, it's polymorphic, and there would be no question about it, right? But like everybody wants to make the if keyword bright yellow or some stupid shit like that. Like this is another reason why I have no patience for all these IDEs that people use, is they use them for the wrong things. But yes, the other point is that we want polymorphism to be intuitive and comfortable. And well, here's the other thing, right? You want your program to be refactorable. So suppose you start and fusel is not a polymorphic struct, and you make like 50 functions that operate on it, right? And then one day you're like, oh, this struct would be better if it had a parameter. And we can give it a default parameter, right? So you could say, maybe you start with, let's call it Barzel, right? Maybe you start with a Barzel that's just a struct, A int and B float, and C is 10 strings, right? And then you write like 50 procedures that operate on Barzel, right? And then you come along one day and say, oh, I want to change the length of the C, right? Well, you could say n int equals 10, and all your code still works because you didn't need to go say template bracket type name fuckity fuck 50 times for all your stuff. You just did one change, right? That's what we're trying to do here, is make it not a big deal to go from a program that's one way to one that is very close but slightly more powerful, right? You shouldn't have this cliff that you have to jump off of. So hopefully that makes sense. So someone is asking, a syntax highlighter that looks up your types to tell you if your function is polymorphic going through your entire code base. No, the way it would work is when you compile the program, the compiler would output type annotations and tags for everything. So your editor would be able to just read that file that's already digested for it and know how to draw things. So your code doesn't have syntax colors until you compile it. Well, again, if you think of it as syntax colors, I mean, if you want temporary syntax coloring for code that's in the middle of being written, you could do that. And then they can be replaced when you have the authoritative thing. But like I said, I don't think syntax coloring is necessarily that useful. I want to know about what my program is really doing, right? And for that, you want the programming language to tell you. So I'm talking about the future. I'm not talking about the present. Yeah, I'm not sure I like the idea of compiling things automatically. That's like very Xcode style. But if you wanted to do that, if you wanted to make an environment that does that, you could do that. Best syntax color choice is highlighting overloaded operators. Right, like, hey, if you want to know if something is overloaded, like that's a semantic thing to know, is if something is overloaded, right? Okay. Anyway, that's the motivation, right? Is now that's not to say that I'm 100% guaranteeing you that this is the right decision, right? We might do all this and we might build a nice program visualizer and stuff, and this is still confusing to some people in some cases, in which case we'll go, oops, well, maybe we should revise the syntax, right? But for now, I feel like it's the right thing because we want polymorphism to be nice. The problem in C++ is that once you're in template land, you're just in a world of pain, and we want to eliminate that pain to the greatest degree possible. Okay. So our gnusto doesn't work for two reasons, as we said. So let's fix the crash. All right. So yeah, so we called infer types, and anytime we call infer types, we could error. And if we error, there's no guarantee that any of these values were produced. So like, why not tell me what the return value of my procedure is? Like the return type, I don't know if to return false or what, I guess I return true. Since we called infer types, we may have errored. And if so, there's no guarantee. Look at this. I'm typing this stuff and it's lagging. You probably can't tell, but I feel the letters coming out like a third of a second after I type them. It feels super bad. And if so, there's no guarantee that call or anything else is valid. All right. So let's try that out. That should fix the crash part. Yep. So now we just have to do the error part, but I'm going to check in my one-line crash fix. Like, did you see that when I quit the thing and then all these like streamed in slow enough that you could see them gradually appearing? It's just so lame. So astonishing. Like, yeah. All right. It's like I could compile my entire program faster than these draw. Not quite. That's a little bit of an exaggeration, but not completely. Okay. Fix a crash in the case of an error. That's good. Fixed it before anyone could file. Oh, let me see if anyone's filed more bugs. Nope. Nope. Someone just edited the Blobman level. Cool. People ask you how fast you can type as if that matters. It's a text editor. Yeah, there's no, and in fact, I believe Casey talks about this in his 30 million line lecture. Like back in the old home computers, you would type stuff and it shows up on the screen instantly. It feels really good. Like you don't even know with modern computers how good it felt to type on those old computers, right? Why? These are millions of times faster. Why can't we just put stuff on the screen when you type it? It's astonishing. Someone says loading file names from a directory is some tough shit. It doesn't even need to load the file names. It knows these are all in its project file. It has this, these are in an array or a linked list. Just draw them. It's not that hard. Am I going to start incrementally writing new compiler code in the new language, or is it staying as a C++ code base? Okay, the hard thing is incrementally writing new code like that is not that easy, because you have to start calling out to a library and you have to share data structure definitions, and there's just a great deal of friction. So what I think we're going to do is we're just going to keep the compiler in C++ until some day comes when the language is stable and we want to do a big re-architecture. So for example, C++ doesn't give you very good support for multi-threading in terms of making sure your program is correct, right? It just, you get some stuff like, you know, the LLVM people did thread sanitizer, right? Which is good, but that's not like language semantic enforced correctness. And so once we have some of that in our language, and we want to parallelize the compiler better so that it's faster, it might be better just to translate it all over, right? And then start re-architecting it. So that's probably the plan, but that's far enough in the future, but that I don't know. Electricity used to move faster in the 80s, so it took less time to get from the keyboard to the screen. Blobman is, was that Abner's test game or was it Josh's game? I think chess was Josh's game and Blobman was Abner's game. Emacs 26 finally has threads. I'm sure that doesn't ever crash. Yeah, maybe it's Carmack's rant on hardware response speed that I'm thinking of, or maybe Casey said it too. Yeah. Okay. So now we have to fix the second part, which is the fact that this doesn't work. So when I make these autopoly parameters, the 0 here is the index inside the struct, and we don't really need that because it's actually redundant with the name. What we need is when this gets lifted up to the outer procedure, then we need to start tacking on numbers, right? But it could be lifted multiple times. So we need a way to sort of go in and change. And I think we'll be able to do that. But it'll be slightly interesting. Okay, so let's find the autopoly declaration. Atwo autopoly. Okay, so we don't, like, this index is not good. And this whole comment is something we're going to change, so we can delete that. And we've learned to live with this, so we're deleting the UG. Let's do a line count. Where are we at? 41563. That's down 5 lines from this morning. That's great. Okay. So we've got this autopoly, and you know what? We're just going to compile. What happened? Oh, because yeah. Make unique polymorph variable. We're going to take out the index. Now what's going on? Now we're trying to use it. Yeah, that was the only use. Okay. So I'm in the wrong folder again. We're just verifying that we still get the error and all this. Okay. So now there's no number on the end. That's fine. Now, when we steal this, was the stealing in ask.cpp, is that what we learned today? Steal. Okay. When we have an argument and it's polymorphic, we steal it. Oh, wait. We do need the we do need the index. We do need the index. Put it back. Put it back. We've made a mistake. It just needs to be different from what it was. Was it here? Yeah. The index that we need is not the index of the thing in the constants block of the struct. That's redundant. It's the index within the lambda. So we're going to take that and we're going to go down here and put that, and then because I unfortunately made it a method, so we have to do this. Why do I still program in C++? And then, oh my God. We do not know the argument index within the lambda. That is not information that we have. Okay, so really what we just need here is a unique identifier. It doesn't have to be the argument index within the lambda. But I also kind of want to be able to do reproducible builds and stuff. So if I use... Oh, maybe I shouldn't worry about that. I'm not going to worry about it. Okay, so instead of calling it argument index within lambda, we're going to call it, because the thing about reproducible builds is it'll never be exactly the same if you're multi-threaded. So like reproducible build has to be an option on top where you like sort your procedures afterwards so you're sure they're in the right order and stuff. So it's something we will have to engineer. And when we engineer that, we can take care of stuff like this. So this is going to be just unique number within lambda, right? And then let's just rename it everywhere. So we're going to call it unique number. So there, and, well, now we're not passing that. So where are we not passing it? 5646. So it's parameter 3. No, parameter 1, 2, 3, 4, and that's going to be inst s. You know what? Yeah. So the problem is inst s is 64-bit. We have this temporary truncate to S32 that we can call. The goal of this function, I don't want to just cast to S32 because I want to be able to audit this later. God, this is so slow. Let's compile the damn thing. All right. Well, I passed the parameter to the printf, but now I'm not. You know what? Screw it. We're just gonna S64 it. Like, why bother, man? So we're just going to say inst arrow s, which is the unique ID on this type instantiation. Is that going to break later? I hope not. I hope not. Let's see. Okay, and then S64. Okay. Why not use the name of the parameter? We already have the name of the parameter in there. Oh, you mean the name of the lambda's parameter? Because we don't know that either right now. The structure that we have access to is just the type field. In fact, the parameter might not have a name. You can, in a lambda header, you don't need to use names. So we only have access to this type field. Hey, look, it worked. Okay. A doesn't match, B doesn't match. Let's make a foozle that does match. I need my list of enchanter series spells. This is this. I'm finding tons of random D&D stuff. Okay, here we go. Aim fizz, fooz 1, fooz 3. So we're going to say fooz 3 is a foozle int, and fooz 1, fooz 4 is a foozle fooz 2, fooz 2. No. Aim fizz, fooz, okay, so fooz 1 to fooz 3, fooz 2 to fooz 3. Let's just do that. We don't need this one. And instead of aim fizz, we're going to go bosbar. Can't believe I don't remember these names. Type mismatch. Wanted type given fusel.poly. Oh, we need a type of. All right. A doesn't match, B doesn't match. A matches, B doesn't match. A doesn't match, B matches. So this is actually performing as advertised. That is great. So now we say auto poly works better when there are multiple auto poly structs. Okay, however, oh, this is going to work actually. I thought that we would have to do something more sophisticated. But that serial number is not only unique within the Lambda, it's unique in the entire workspace, which means I don't need to do anything else. In fact, I hadn't thought of that, but that would have been a good solution if we didn't have that serial number, would be just to have a unique counter for autopolys that's like on the whole interp system and just increment that all the time. So let me test convoluted. This is going to be a convoluted test. So in what way are we convoluted? Well, we're going to take procedures as arguments, and we're going to take F is a procedure taking well, a struct of some kind. We'll just say some type to a string actually we want to use that variable. Oh, we want to use autopoly. What am I doing? We don't want to say $t. We're going to say S is a fusel to a string and T is a fusel to a string, right? And the point is, this is like 2 layers down now, right? We have fusels, they're the same argument index, they're 2 layers down, and they end up, these parameters end up unconvoluted, actually, right? So we're going to say S1 is, we'll say A is a fusel of, well, let's just, fus1 is a fusel of float 64 and array of 10. I don't think we parsed that yet. Type array of, that's a thing to do today. Okay. Array of 10 U8s, right? Fus2 is a fusel of type of fus1, type of fus1, right? And let's get rid of, we'll say print prefix F result, let's just put the prefix here. F result prefix F of fus1, G of fus2, right? Let's make sure that even compiles before we try to use it. Okay, it does. Great. Now, we need to make some things that we're going to pass in. So we're going to say proc A is, well, it takes a fusel, right? We'll do something interesting. First, X is a fusel to string, and S is tprint percent comma X. We're just going to print out the struct, return S, right? So does that compile? Yeah. So now we have something. We can say convoluted of Gondar. It's going to be our new prefix with proc A twice. Program contains circular dependencies. Interesting. And it's not telling me what they are. That seems like a bug. That seems like a bug. Oh. No, we just need a better error message here. This is not, it's not circular dependencies. It's just, we don't resolve all our types, because at the end of this, we still haven't said what the hell the fusels are. So, well, whoops. To do a reasonable error message for this. Okay. The reason is, like, nobody ever, like, fusel is still an abstract type that could take anything, and the fact that we pass it things in here doesn't actually help. So, you know, I concocted a thing that's so convoluted that we kind of don't know what to do. If this was a macro, it would work, but we don't have macros. I think it would work if it was a macro. Right, so, you know, we don't do arbitrary type inference in all directions, right? The way procedures work is the type inference comes from procedure substitution, right? So, so what do we do here? How do we make this something where the type can be fixed? Time to implement macros. Yeah, no, not really. This, however, oh, here's a thing to do. Interaction of auto poly with default struct arguments. If this struct has default arguments, we actually don't want to auto poly that parameter. So a case in which this would work is if fusel had a default argument. Okay. But that's not what we have going on here. So let's do this. Instead of having these value 1 is a foozle and value 2 is a foozle. We're just partying down, right? Value 1, value 2, right? Now, we're actually going to bake these out. So, yeah. So we're going to do this. This was our thing that doesn't give us a good error message. So we're going to make 2 foozles. Okay, let's make sure this compiles. Okay, great. We're not using it yet. So we're making 2 foozles, and we're going to say proc A1 is going to be bake how does my proc A work? I think I can say this. I don't know if that's how it works. Identifier expected. Yeah. We have a hole in the language semantics. There's no way, because I did bake a long time ago, there's no way to specify we could do this. If that works. Okay. So give me the procedure that would result from this call. We should maybe do that tonight. So here's the thing. This is not even a thing with polymorphs, but also with overloads, right? Say there's some overloaded function called foo, right? And you've got like 10 of them. And you want to say, give me the foo that operates on ints, and I want to pass that function pointer somewhere. I want to store that in memory even, right? How do you do that? There's not really a way to do it. I don't think there is in most languages, right? But if you could say, resolve the overload for these parameters, and then tell me which function that would have been, instead of actually calling it, just tell me what it would have been, then you can use that in a number of ways. You can use it for baking things. You can use it, in fact, I might get rid of some versions of bake then because it's more convenient. We'll see. I don't know if this is going to work now. Let's see. Proc A1, proc A2, foos1, foos2. This is getting very convoluted. Okay, this is not something that should ever happen. Did not find an identifier named autopolysum whatever in the constants block. Oh, yeah. So this is a problem I had before. What's going on is the number when we copy we're not copying the autopoly substitution, I think. And so we're redoing it, and the numbers are changing because the instantiation has a different value. So we have to save the fact that we did an autopoly substitution, or something like that is happening. So Well, this is why we're doing these convoluted examples, to make sure that this is more robust. Bake does give you the procedure. Someone's asking, what does bake do if it doesn't give you the procedure? It does give you the procedure, but the way it works is you tell it the value for each type parameter. And the reason I was stuck for a second was that if you do this, you don't know the name of the type parameter. It's like not a user-facing name, right? So you have no way to bake it. And that's sort of an error in the conceptualization of bake. It's just that it's older. Bake came way before this auto poly thing. You know what I'm saying? Bake does require all the parameters to be baked. Yeah. Yeah. Well, so the question is, which part of this isn't working? Okay. When we do auto poly, we save this generated auto poly call and this inst generated auto poly declarations. So when we copy it, as long as we're copying these things, it should be okay. And in fact, the reason I stashed this here, well, it was, okay, let's look in copier. We do copy that. And we copy this. Well, given that we're doing that, it's not clear to me why this is happening, so we gotta debug it. So when I say I'm going to look up did not find whatever, and we're going to break there. Now, whatever we're looking for, if the numbers in the constants block are lower than they came earlier, which means this is a later copy. If the numbers are higher, then the ident is a later copy, I mean. If the numbers are higher than what's in the constants block, it means that the identifier was recopied later, but the constants block, or the identifier was recreated later, but the constants block itself is older and being copied correctly. One or the other is not happening. One of these things is not like the others. Or maybe a third thing is happening that I'm not even imagining right now. Okay, boom. Did not find an identifier in the constants block. All right. Well, let's look at the constants block. Dear Constance, I miss you. Members 4. Well, we have an identifier that's, I wish this debugger didn't suck so bad. 10000D7, and this is C2. So this is newer. Let's keep looking though. D7. D7, right, that's A and B. And then these probably have a higher number DB and DC probably? DB. That's weird. Oh, because that, right. Okay, this is strange. This is strange because we've only got 4 parameters in the constants block, and that is from F and G, but we don't have any from value 1 and value 2. So really, what's going on is we somehow didn't copy value 1 and value 2 from the previous. We didn't copy those constants block entries. Let's make sure that that's really what happened. So when we look at this lambda, we should be able to look at who it was polymorphed from. And let's see how many block entries that has. Polymorph source lambda blah. Oh, 0. What? What? Okay, this is the original one. So that means our steal didn't work on. Maybe when we steal things, we're not. But we correctly do before. What? What? Oh, maybe this isn't from F and G. Maybe it's from value 1, value 2. Okay. Let's cut this down for a second. Let's see if we can find a simpler thing that still has the problem. So what if we get rid of those? What happens? Well, we have to comment this out because there's no value 1, value 2. Okay, it compiles. Oh wait, that was Sokoban. Duh. No, we still have the same problem. Okay. Do we have it here? Is this just a 2 layers down auto poly problem? This is not convoluted anymore. Let's just call this one basic. This is basic. You're so basic. Okay, so we've got basic and basic proc A1. So this is just a much more fundamental thing. So maybe we just failed to steal it. So maybe it's in the constants block of F and it just didn't get all the way up, right? So what happens if I do this? Where's basic? If I just do this, I bet that probably works. Yeah. So there's some difference between what auto poly does. We like don't mark the variables correctly or something, which is weird, but it is what it is. That's what we're here to fix it. Where do we put this into the constants block? I know we do it. Make unique polymorph variable. That's where we do it. Okay. So we add it to the constants block of that lambda. I bet this is happening too late. It's happening after the steal, maybe. Who calls put arguments into lambda? Yes, that is a parse time situation. So the problem is when something like fusel is polymorphic, good thing we're testing these things. When something like fusel is polymorphic, we don't know that at parse time because it might not be defined in the same file. It might be in someone's library. We have no idea. And this is not like C++ where the header files give you everything in advance. So we have to wait until we've inferred the type of this to know, in fact, whether it's polymorphic or not. You dig? Dig what I'm saying? So, I mean, I'm pretty sure we can verify this by, we're just going to break in the same place. We're going to look at the lambda, and it's going to have a lambda arguments declaration. Arguments block, members, data, 0. This is a lambda. If we look at the type inst value, no, type inst type of lambda. Okay. So this is the argument, and this argument has a constants block with members in it, one of which is identifier 100BE, and is that the one that we're missing? BE. Yep. So that is what's happening. This is happening after the official polymorph steal. So that's a drag. So we have to fix that. Okay, any questions about what's going on while I cook a tea? We're going to come back and fix this, but I need some warm liquid. Questions? Tell us again what's wrong. What's wrong? Okay, so I started out this morning even talking about the way polymorphism worked, back when I thought I was going to change the way it worked. And the way it works is, in a case like this one, where you have multi-levels of polymorphism, right? We have a procedure, and then another procedure in the argument, and then a polymorphic thing in there. The way this works is by taking the names of the polymorphic parameters and propagating them all the way out. That's what I call a steal, right? So if you're a function, you take another function as an argument, and that function has polymorphic variables. You steal those variables for yourself until you get to the top level, right? It just comes from the fact that, you know, when you're parsing, if you parse something like this, you're parsing a struct declaration, and that struct has these. But really, you want A and B to be in this whole space. So that's what stealing is for. And then when you say fusel without the parameters, we're making things just like A and B, but they're invisible, right? The problem is stealing right now always happens after parsing. But type checking has to happen after parsing also, and it has to happen after steals. So, you know, when we're determining that this is polymorphic is too late for the steal to happen, basically. So we have to add another time when a steal can happen and hope that we don't run into some insurmountable problem structurally in doing that. Like, I mean, I could think of some reasons, but hopefully it's okay. Saw that I'm streaming a lot these last 3 days. Will this be uploaded on YouTube? Yes. The first day or two are already on YouTube, and I'll probably upload yesterday's today and today's tomorrow. So autopoly is happening after polymorph steal. Yes, exactly. Right? So the idea should be, okay, we make these autopoly declarations. Let's go back to basic. The idea should be we make these autopoly declarations and then add them to F, which we do successfully. So we add them to F, and the idea is supposed to be, because basic is outside F, basic is supposed to steal them away from F. But that doesn't happen because we did it too late. And so then when we try to apply basic, you know, it's trying to look up these variables, and they don't exist. Now the question is, why are they not found inside F in the identifier lookup? I'm not sure. I think it's because the scope of the identifiers gets set to basic. I'm not going to worry about it, because the way this is supposed to work, it would work. Okay. Against my better judgment, I'm having tea with caffeine at 7 p.m. Do I think to save time, it should just lazily perform steal when identifier isn't found and then recheck? No, I mean, I'd rather not have things changing at random times like that. I would rather have a well-defined time at which it happens. Although, if you did that, then you would be sure that you could never do it too late, right? That's the upside of that way, but I would rather not do it that way. Are there any plans for a standard data format that the compiler will output for editors to use? Yeah, I mean, we'll make a data format that is well-defined and expandable. It'll be a binary format, none of this text bull crap. I mean, maybe it'll have a text version for debugging purposes, but the standard version will be binary. And yeah, and we'll just see how it goes. Well, I'm glad you think I do a good job of explaining the problems. I'm doing my best. Well, I'm also trying to strike a balance between spending forever explaining and not really doing any programming, so the explanations sometimes are curtailed, but What's a data format? It's just a description of how to read a file. Like if you're going to load a file, how do you know how the information is supposed to be laid out, right? That's all. I see. So the question was the following. The question was, I was talking before about how your editor could, highlight things differently based on the semantics of the program, like if a function was polymorphic, which you can't tell syntactically at all, right? And stuff like that. And, that information somehow has to get from the compiler to your editor, right? And so the answer was, well, you'll be able to have a meta program that when you compile your thing will output a file that succinctly describes the types of everything and so forth. People are asking what I am eating. I'm eating some Chinese snacks that are a bunch of seeds and nuts stuck together. Oh, this one that I got is all peanuts and a little bit of sesame seed, but some of them is black sesame seeds. One of them is like sunflower seeds and stuff. I've also got an aloe drink. It's Asia Day, I guess. Someone's asking, would it be worth it for them to go watch all the videos? Well, only you can answer that, I think. But I will say that the videos are divided into two categories on YouTube. There are videos that are official presentations, and those tend to be information dense with not a lot of messing around. They're pre-prepared, and they tend to be showing exactly features, right? And then there's videos like this one that we're recording right now, which is just me working on the compiler, right? The former ones, if you were to watch those, it's a lot clearer to see a definite benefit in terms of understanding the language. If you watch all these, you'll probably understand it even better, but at a much higher time investment. And so you could sort of pick how much you're interested. I don't think that primer on GitHub is a good place to send people. It's not really accurate anymore, and it never really was. Do we have any plans to optimize runtime performance? Absolutely, yes. We want this to be as fast as possible. It's just we're not at that stage yet. We're still defining the language, and as you can see, we're still making some features work. Can you write an email to Abner to compile? I wouldn't put him through that hell, no. What's the most awful hack in the compiler today? There's not a lot of super awful things left. I've been getting rid of them. I would say the worst one is the different ways that dependencies happen. And the way that things sleep and all that. Like, there's no way that it's all correct. And there's going to be a bunch of weird bugs about that. So I would like to find a way to simplify the dependencies. And I think it's not too unreasonable to expect that. We'll see. Is there a separation between logical and bitwise and an or? Yeah, there is right now. And do logical ones have early out? Yes, they do. You kind of really want that, actually. Do you have 100% feature parity? Yes, we do. The other guys work mostly on Linux, I think. I'm the person who works mostly on Windows on this compiler. This aloe drink isn't that good. Okay, let's get back to fixing this. What the hell was I doing? I was making the steel. I was going to factor the steel out so I can call it from another place. Whoops, wrong focus. Hocus focus. So I need to see how much of this steel is I think I just take the part I'm not even sure in what case is this decal expression thing even valid. Okay. So I'm going to say this is going to go down. And we're going to just factor that part. We're going to say steel constants block entries lambda arg lambda, right? That's all we're going to do. How about move? We'll go move. I never know whether to make things dest source or source dest. If it was all my code, I would go source dest. But you know, stuff like memcopy and memmove go dest source, and then because of that, a lot of people do that, and it's just really confusing. Whatever. And the way I thought about it this specific time was dest source, so we'll just see how that goes. Memcopy is wrong. Yeah, probably. I mean, the way they do it that way is because when you say A equals B, the dest is on the left and the source is on the right. So there's a logic behind it. It's just, it still is weird to me. Oh yeah, it also mimics assembly language. That's true. The stream keeps freezing. I was dropping frames earlier today. Let's see. I'm dropping about 3% of frames. That's probably not enough for you to be freezing, but it is enough to be a little bit of droppy. Okay. Steel constants block entries. And then we're going to put this in the header file so that other people can call it. Call it, bro. Steel constants block entries. Now the question is if we set the resolve declaration. Well, whatever. Okay, so when now we're inferring, let's just make sure this compiles. I probably forgot something. I'm reading chat half the time. Oh, this is dest source dest source interp. Okay, let's pass that. Don't arrest Constance Block. She's nice. Okay. So we still have the same problem because we haven't changed anything. We just factored this out. So now when I go to check function header, really when I steal Constance Block entries, I'm going to try doing it a different way. Let's make sure Sokoban still compiles. So here I'm essentially dropping the declaration and making a new one. But I want to keep the declaration because we will have inferred its type and all this. So because we inferred the declaration, colon is from typer, don't make a new one. So remove from scope, that's a thing, right? Remove from scope. Oh, well, we don't need that. It and closing. Do I call checked add to scope? Let's just call direct add to scope. Where's a non-checked? Interp dest constants block it. Let's just see if that works for the old program. Oh, we're compiling debug build. Oh boy, I haven't been testing what I thought I was testing. Hate that. Common mistake. Hate doing it. Okay, let's see if we can compile Sokoban. Hey. Hey, all right, this is promising. Because, you know, sometimes, like a change like this will make it work more in more situations, but, you know, sometimes that might break things, but it didn't. Okay. So we now have a factored out steal Constance Block entries. Did frickin' C++. I got it. Okay. So because this is passing tests, I'm going to check this in. I'm going to say like that. Okay. Now we got to use it. So check function header. Okay. In the arguments blocks. Okay, if I think that's a flag that we have. We're going to have to, so I'm going to make sure this works for arguments, and then we need to do it for return values. Okay. If it's a lambda, other lambda static cast as lambda. Maybe I don't have that. I do have it. Type of lambda, and I do have that. All right. Assert other lambda. And then what then? Well, if other lambda constants this is wrong. This is not the right thing. So if it type inst and it type inst value define flag, and I must be tired to like type a flag as if it was a field. Okay. So we have a lambda. If lambda constants block dot arrow members dot items, then we got to steal them. Steal constants block entries interp lambda other lambda. Okay. Sometimes we can't tell if an argument is polymorphic until infer time. For example, an argument that is a polymorphic struct. So we can't have stolen this at parse time. So let's do it now. Clean up. Should we only do it now, or is there a reason we need to also do it at parse time question mark? Is that going to work? Hell if I know. Well, obviously not if it doesn't compile. 654. Other lambda is type of lambda. Type of lambda. Is there like a sports game happening? I can hear people cheering out across the street. They're very sports gamey cheering. Hey, will you look at that? Basic compiles. No, I mean, they're cheering at very specific times. It's not the sound of like a bunch of people having fun at a party. It's like something happens and they're all woo. Maybe they're playing party games and somebody wins once in a while. I don't know. Do I have an opinion of voxel-based engines? There's some pretty cool demos on dynamic and destructible geometry. They're fine. I don't know. I haven't seen one that I think is amazing, but hey, whatevs. All right, I'm very happy. So this is bug number 2 in polymorphism that we fixed today. So it wasn't all a loss. Okay, so basic. Now let's get back to convoluted. So we went down to a version of convoluted that's only got one argument. Right, so like this, is that my current convoluted? I think so. Does it do anything yet? No. Okay, well since we can pass one argument, let's pass the other argument. Let's pass all the arguments. Screw it. Oh, undeclared identifier proc A2. Oh, because we gotta do that. Okay, we can at least instantiate this function. It's empty. Let's try running it. F result, fusel.poly, blah, blah, blah. G result, fusel.poly A, blah, 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 B, blah, 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 blah. How is them apples? How is them apples? I ask, how is them apples? Them apples, in my opinion, is better than the NHL finals. Why am I a secret Minecraft player? I didn't get it. Did I say something that is a Minecraft thing? I'm not on crack. I'm just tired from streaming 4 days in a row. I don't know how Shroud and Choco Taco do these kind of hours streaming. It's crazy. Yeah, I think I commit this, right? Well, we got to test. We got to test. Let's not get too excited. I might have broke something. Didn't break that. Didn't break this. Hopefully. Blobman still compiling. You can't wreck Blobman. If you wreck Blobman, that's bad. Okay, let me try the x64 version, which would be this. Still compiling in about 1.1 seconds, so that's good. We haven't wrecked anything there. Well, it's been a successful day despite the mishap in the earlier day. Maxwell Perlman is back. All right, well, this is enough to turn it around into a successful day. So anything after this is just gravy, man. It's just gravy. So I think next is reasonable error message for the thing I just deleted, right? This, for some reason, oh, it might have been that it wasn't stealing properly. Let's see if we get a better error message now. Well, okay, right, we changed it. Okay. This is bad news. This is very, very bad news. I think we're infinite looping. Maybe it's because we added the parameters, or maybe it's that the loop solver interacts badly with our steel situation. I don't know. We're going to have to investigate this. 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 How complete is this on a scale of 0 to 100%? Negative 463 plus 215i plus 3.1j plus 2e17k. It's not Miller time yet. It is not Miller time if your compiler infinite loops. It is not Miller time. Yeah, it could be if you have a different approach to alcohol, it could definitely be Miller time because you need to deal with your problems. But okay. So we're just going to run it, and we're going to break. I assume it's infinite looping and not like wedged in some other way. So let's break. It's probably in the looping polymorph solver. Well, we're definitely polymorphing. Sort call arguments. Make polymorph of called procedures. Is copy and force types and blah, blah, de blah. Well, I think what's actually happening is that we keep, there's all these pipes in the compiler. And how do you know when you're either done compiling? Well, you're done when there's nothing left in the pipes. How do you know there's an error? Well, there's stuff left in the pipes and the pipes aren't moving, right? It's like the series of tubes and the junk gets caught in the series of tubes. But if you create new stuff every cycle and throw that away and don't account for the fact that you threw it away, then that could be counted as progress and the compiler would never stop even though there's an error. And I think that's what's happening. That is my theory about the Brontosaurus. Maxwell Perlman is young enough that he doesn't remember Senator Ted Stevens and the series of tubes, which came from the whole last time there was net neutrality. And I always thought it was stupid that people made fun of him because what do you think wires are? They're tubes that electrons go through, okay? Your connection to the internet is a series of tubes. That's just how it is. Yeah, if you have a fiber optic connection, it's a tube that photons go through. If it's Wi-Fi, it's still functionally a tube, even though it's going through the air. Can I bump up the font size on Visual Studio? Well, for the text here I can. For these other windows, I have no idea how to do it, so sorry. Okay. Look, it's a tube. Like, you have a certain limited band in which of frequencies, right? And within that band of frequencies, there's, you know, if you put waves that destructively interfere with each other, or how would you say it? If you put waves that exceed the Nyquist limit, then nobody's going to be able to decode it, right? So there's a limit. That's what bandwidth is. It's the fact that your connection is a tube. You would have a really big tube if you put the universe in a tube. Okay. So well, I just want to see what happens here. I mean, am I infinite looping somewhere in here, or can I return all the way out? Okay. We made a thing. Let's double check so we know what we're talking about. Bug 174, test line 37. Okay, so it's one of these auto-poly situations. So we're in a force infer itself, which is a little confusing. Let's see if we can return back up to that. We finished it. That's good. So we made our lambda. We successfully made an entire lambda. And it should be polymorphic. Right, so the flags are 20240. I believe 200 is polymorphic, right? 20240. So it's a polymorphic lambda of which we actually only want the type, which means this is one of the arguments. Which it is because we're sorting call arguments. So that's fine. That is fine. It should have an MC constants block. Type of lambda. Boom. Constants block. Members. 8! Wait, this must be the upper function then. This must be, I bet I could look at the name Convoluted, yeah. So that's the upper function. I was a little confused about where we were, right? It should have 8 because it's got 2 for that, 2 for that, 2 for each fusel, and there's 4 fusels. And they all could be different types of fusels. That's the point. Okay, so solve for matches. We're in the loop solver right now. But we're not infinite looping in the loop of the loop solver. So I bet we return here. Success, false. Question is there still something in the pipes? Well, I'm sure there's lots of things in the pipe. Num output, num input, num thrown back, num unqueued. We're probably queuing some lambdas and yeah, let's return out. If I'm correct about my theory about the Brontosaurus, we should come back here again for the same call. So success is false. Yield is set. We're waiting on a struct. Let's just wait till we're back here. Call S. Conditions. Call S is this. Continue. We're back. Address of yield. Breakpoints. Data breakpoint. OX471B4A8. Continue. Okay. We're yielding upon a struct because it has not exited the infer pipe. It must be it's a match, but it's not. It must be the result of a copy that we just did. You know, this is the same problem that we had before. Like yesterday or something like that, I was checking the pipe, but in a force infer, you can't do that because we don't set the pipe. We just infer the members. So I bet all the members are inferred. It's the same problem. I don't know that it's the only problem, but okay, struct desk scope members dot data comma 2 to see both members. First one is an identifier called A. It has an inferred type. The second one has an identifier called B. It has no inferred type. Interesting. Oh, because, I mean, we're in the loop solver. Wait, why isn't this polyuse? This, if we force inferred this struct, identifier, resolve declaration is null. That's real weird. Both of these don't have a resolve declaration, but A, wait, it's inferred, what? Oh, the declaration's inferred type is set, but the expressions is not. So the declarations infer, right. Okay, that makes sense because it's a force infer. So I was looking in the wrong place. Here, inferred type is set. So this is the same problem as before. I need to find that comment. I think we said can't, something we can't use. You know, usually when I try to search for a comment, I'm wrong about what the phrasing was. Does anyone remember where this comment was that I was talking about? Because that's our current line. Got a lot of can'ts. My eyes are glazing over trying to read this. Like, why is my syntax highlighting not active here? Because I would like to actually skip to the comments. How's chat doing? Okay. Well, I was gonna let's just look at where this is being called from. Check for yield. Yeah. Okay, so I don't know why this wasn't screwing us up before, honestly, but let's fix it. Well, we have to check the members. If this struct is force inferred, it will be newly created, not exited pipe infer, yet all its members and constants block entries will be inferred. Refactor. We did this the other day somewhere else in the program, but I don't remember where. We should make a common test to see if a struct must be yielded to or not yielded upon. Okay. Should yield equals false if should yield. Okay. For just make a more convenient name. desc constants block dot members. Dang it. Inferred type should yield equals true break. Okay, something like that. I don't know what's going on. Bruh. Wait. Members, constants block. Arrow. All right, well, let's run debug build here. Because that was kind of scary what we just did. Attempt to use polymorphic struct fusel.poly as a value. You can't do this unless you specify all its parameters. That is a good enough error message for me. I mean, let's make sure that it's really about the problem. I mean, so we know it's something to do with proc A. Ideally, we would get the procedure call site because this is not telling you where you're calling it from. And that's really bad news, but we're going to do a whole like goodness in polymorphic error messages sometime. So for now, we're just making it work. Okay. So this is good. Well, maybe we should do this now. I mean, let's find that error message and see if we can do a special. Well, first let's check in. Let's make sure we didn't break any of our normal stuff and check in, and then we'll make that error message better because that really is unfriendly. Have I played Disassembler by Ian McLarty? Nope, I haven't seen it. Have not seen it. Okay. Sokoban. Build. Sokoban X64. Make sure we haven't taken a speed hit. Less than 1.1 seconds still. 0.54. And run tests. What I really want to do is parallelize the type checker, man. That'll take so much time off our compile time. Actually, that's kind of what I want to do tonight. Is I said this thing about messaging. I just want to do that because then we could use LLD. And that'll reduce our compile time. If we use LLD instead of link.exe. What about TIS 100 or other Zachtronics games? Yeah, I've played all the Zachtronics games. All of them. I have played all of them. Okay. Do I have any tip on staying motivated? I said stuff about that in the past couple days, and I don't feel like anything I say now is going to be as good, so you could check that. I don't remember, unfortunately, when I said it, so Just be motivated, man. Well, I really liked Opus Magnum probably the best out of all the Zachtronic games. Maybe TIS 100 second place. It's hard to compare because I played them far apart from each other, and hard to compare. Tools, options, fonts, and colors. That sounds complicated. Sounds complicated. Okay. So what did I just say? I said I was going to improve. Well, I was going to check in. That's 3 polymorphism bugs that we fixed. There's got to be so many more, which is why I would like to simplify the implementation, but I just don't know how yet. I do not know how. Okay. Oh God, there's that returns incomplete thing. We got to do that. We got to do that. And then... Oh, and then this. Okay. Better yet again, error message for Gondar there. Okay. Before we do that, we've got to find our returns incomplete. Right there. Typer 652. If is stealable, if is post type check stealable lambda, we're just going to make this shorter. Post type check steal constants block entries interp lambda it. We're just going to make this easy because we're pasting this into multiple places. So ask.cpp post type check decal type inst steal constants block entries interp dest other lambda boom boom. Okay, and then is post type check stealable lambda bool ask declaration decal whoops. Wait, so you don't need a cast to lambda here. And you don't need to check that because that's pretty safe. You just need to check that. So return true, return false. What? I missed a parenthesis apparently. Oh, up here. So we're just going to put this inline in ask.h because it's going to get called for every argument. Okay, so we're not even going to put that in the returns yet. We're just going to because you could return a procedure that has, you know, that returns a thing. We can maybe test that. Okay. So I deleted the returns incomplete. Let's see if we broke anything. Release build, test. Okay, great. Now, let's try to test that. How do we test it? There's no real way to test it right now because we would have to bake. Oh, no, there's a way to test it. Okay, so test return is x int or n int to a procedure that takes well, n int and returns a fusel, right? Let's put that in parens to make it more readable. Otherwise, it looks like Haskell. And we don't want to look like Haskell because that crap is unreadable. Okay, so we're going to say F is a fusel of float float. Oh no, that's not what we want. We're going to say return thinger, where thinger is a procedure that goes from n int to a fusel of float float. X is a fusel of float float. X.A is cast float n, and x.b is cast float n times n, right? So we're putting n and n squared in the thing. Let's see if that even frickin' compiles. It'd be a miracle. Expected only a, we need this. It's a miracle. Okay. Test return. We'll say thinger is test return of well, we're just going to do that because we're not, yeah. And then, wait, that's not going to work. It's not going to work. How do we make it work? So once again, right, we don't do type inference from return values, right? And this has to be fixed by the call. So again, we have this weird thing where well, we can do the bake thing again. We can do this. That's a parse error. Oh, I guess we don't do $t/ there. And if we did anyway, it wouldn't solve the problem. Yeah, see, here's the problem is I have no way, I could bake this, but there's no way to express that. So we're not going to worry about it. We're in fact going to go back and say, what was our stuff called? We're going to say, as far as I know right now, there is no way to express the baking of a lambda that has a polymorphic struct as its final return type unless you put a $t/ or something in there, in which case we would have already known it's which we don't parse at this time, and I am not sure it even makes sense leaving this in here in case we realize it does make sense and know what to support and test. Okay. So that's fine. That's fine. Let's make sure we didn't break anything. Authoritative just means, okay, look, so say you've got a function and two of them take t, which is the same type, right? So let's go to array adding, right? So, oh, it's an array. So we've got array add, and you pass it an array that's got elements of type t and then some item to add to the array. And let's say you get it wrong. What should the error message say? Should the error message say array is the wrong type, or should it say item is the wrong type? Well, cognitively, what we say is the array is by definition the right type because it's kind of more major. And if you do the wrong thing, you're passing the wrong item, right? Another reason this matters is, okay, well, what about something like struct inheritance where you can have an implicit cast to a certain type, right? Well, if this is the type, then if you add an item that can downcast to this type, then it's fine and you'll successfully put it in the array. If this is the type, you can't like downcast a whole array of things. That's just not how that works. You'd have to mutate the array to change the pointers, and well, not always, but that's just not how it works. So then you wouldn't be able to add the item. See what I'm saying? See what I'm saying? That's all. Okay. Test. Sokoban. Run tests. Okay. This is all good. Check in a refactor. Infer time polymorph stealing. I used to steal polymorphs at infer time, and then I decided at some point that I didn't need to, and now that's wrong, which is why I commented it. Okay. Next. How are we doing for line count? 41607. We're like 40 lines up from this morning. That's a lot of code. That's like 0.1% of our compiler size. We got to be careful about all this code we're adding. How often do I stream? Well, I go through long times of not streaming at all, and then the past few days I've been a stream maniac. Constance Block Factory. Maybe. That's a good idea. It's a good idea. It could be like Pink Floyd, another brick in the wall where Constance Block is in the factory. Okay. What? I had a thing. Oh, yeah. We were saying, let's make that error message better because it's downright crappy to... It's downright crappy. I'm going to email Abner later, so I'm going to put it at the top. Hey, Abner, here is the advanced polymorphism test I was talking about. And we're going to add that so I don't forget. Because, you know, we want to make regressions for this. So I'm making it work now, but chances are these things will break at some point in the future. And if they do, I want to know that they broke. Bro. Okay, so we need a better error message for Gondar. Wrong shell. And by better, I mean we need to tell people where the call is. Right back while this compiles. I'm going to make some more tea. Still waiting for the tea to heat up. Waiting for my tea to heat up. Waiting for my tea to heat up. While looking on my phone. Looking in Twitter on my phone. You're invited to return to Sandhawk for a 4th round of testing on the experimental server. The test begins May 31st. They should just release the damn map already. I don't understand what their problem is. They should also announce another full-size map. Okay. All right, we're off the caffeine. I gotta get some milk. All right. I bought a giant cafe-sized tub squirter thing of my favorite chai. At least it's my favorite when I'm in New York. And I gotta make some. Oops. Okay, we are gonna break on that error message. Sort arguments. That's not where we want to break. That's the wrong place. Here we go. Can't do this unless you specify all its parameters. Here is the struct in question. Question is, how do we get back? If interp reported error, interp report no label site while polymorphing a procedure from a call here. report no label just makes it not say error. Let's see. Wait, did I not? Oh. We've got to put this before the not success. Come on, bruh. It's almost like you can't program. Okay. I'm going to capitalize this W to harmonize it with the here. But I actually want to, how do I decide? How do I make it? Could I just say disable showing context? Oh, if it's not no label. I don't know, info. I always get no label and info confused. It's almost like I can't program. There we go. So now people see the call site. Because if you don't give them that, this, maybe that you got lucky and they were just editing this couple of lines of code and made this error, but maybe they were editing like the struct declaration and they have no idea what the hell happened, right? So you gotta trace it back to the source and tell people what the problem was. Let's make sure we didn't break nothing. Do talks and blog posts really take FizzBuzz seriously? My understanding of FizzBuzz, in my day, this thing didn't exist, right? My understanding of it is that it's a minimal test of competence. Like Google and people give you the FizzBuzz test in order to determine if they should reject you because you're just saying on your resume that you can program without even being able to program, right? Like being able to do FizzBuzz isn't supposed to be like a sign of competence. Not being able to do it is supposed to be a sign of incompetence, right? That's all it is. That's all it is. It's like the brown M&Ms, okay? FizzBuzz is the brown M&Ms of programming. Except not at my company or anything, but that's my understanding of it. At these other companies. Okay. Well, so I can take that comment out now. Whoops, test. This one now concerns me, but better error message when type checking fails internally to a polymorph. FizzBuzz would weed out 90% of applicants. Wow, that's crazy. I guess the applicants are pretty damn bad. Pretty damn bad. FizzBuzz test using church numerals only. Okay. Okay. I think we're on to the last task for today's stream. There's a whole different thing that I could stream, but maybe we'll do it tomorrow or later. But this is still related to polymorphism. Maybe it's going to turn into a total hell task and I'll regret doing it. But I kind of just want to chill and watch some Choco Taco before he goes offline. So I'm going to hope it goes fast, or maybe I just won't do it tonight. Maybe it'll go on the to-do list. But we need a test of has default is a struct, has one default, one param, is a struct, n is 10, x is n. Okay, so P1 is a has one default, one param of 5. P2 is the same of nothing. Print P1 and P2. We still haven't got to the advanced part yet, but if this breaks, then we're really in trouble. So let's test it. Wrong shell. Oh, well, we got to comment out our Gondar. Okay. Oh boy. Well, that's got to get fixed. What happens if we do this? Okay, that works. So I suspect we're trying to do auto poly in a bad way. Yeah, so we're getting x equals 5 and x equals 10. That's great. But the crash is no good. The crash is no bueno. What if applicants used to write in Haskell and the programs simply don't side effect? Then they fail. Ammunition is doing Legos. Well, that's good. Okay. Oh. Yeah, that's not a good thing. See what the hell this is. Actually, okay, let me see if we assert when we put the parens in, right? Or if that's only... No, we don't assert. Okay, so that tells us more. We have more information. Now, I bet this has an auto poly name. No. Oh, it's P2 completely. Why would it not say stack allocated? Because its type is something weird. It's polymorphic. It's polymorphic, which it should not be, which means we auto-polyed. So maybe do auto-poly line 126. Conditions, site arrow line number is equal to 126. Okay. Oh wait, 125. I always do that. If you make it look like there's a blank there, don't exit if I click where you make it look like there's a blank. All right. So what we want to do is, instead of generating auto-poly declarations for each frickin' thing, if there's a default value, we want to put that in. Can we assume that the constants block is in order? I'm going to say yes. So we have a constants block. Wait, what? What just happened? We're not in an appropriate type to do. Oh, right. This is not an auto-poly situation. I braked in the wrong place. This is just a regular struct instantiation place. Here's what's going on. Ooh, this is troublesome. Instead of doing auto-poly, in maybe do auto-poly, what happens after we return from this? We do this stuff where we do all this craziness, which frankly we want to do. Actually, no. What we want to do is well, we could do it. We could do it. So if we're in an imperative block, then the meaning of this, you don't put $signs in. We just do this. So we can check for that. We can say, okay, you're in an imperative block. is not only imperative block. It's really imperative or data declaration. It's anything but those other ones. It's okay. So let's start just working this out here. So okay. Bool insert variables equals false if it's arguments or returns or struct arguments insert variable equals true. Insert variables. Now there's two things we have to do. We have to make the non-insert variables case work. And then we have to make the insert variables case work if there are default arguments. Okay. So if we don't insert variables, then we simply leave the call with no arguments. And I hope that works. Who knows? Hey, there we go. That is good. Let's make sure we didn't break anything there, and we'll check that in. We're going in baby steps because I'm tired. Tired. Could you implement lazy infinite sequences? I haven't thought that much about lazy evaluation. It's not my favorite thing. So I guess we would have to look at a specific problem and decide if that is implementable. I don't actually know. Okay. Build, run. Run tests. Kabam. Kabam. Okay. That's great. Check it in. Okay, well, what happens, just for the sake of arguments, has one default, two params, and we're just going to leave it empty. So this should be an error, but I just want to see. M is an int. Struct instantiation is missing argument M. That is great. It tells us where it is, etc. Awesome. That is exactly what we wanted. So now I want to say 7, right? This should work. And then P4 is, I don't know, it's not very interesting. P3. So now we need something that will test this as an auto poly. So we're going to say auto poly with defaults is X has one default to params S string devoid and print X equals whatever X prefix. We'll call it prefix because we did before. We put prefix second. Let's put it first because that's how we're doing it. Come on, consistency. No whammies, no whammies. Okay. Let's just make sure that even compiles. Okay. Compiles and runs. We have not called this yet. My suspicion is when we do, it will not. Oh. It will work because there's no way to specify only one parameter. Actually, this doesn't really test anything too interesting, but hey. Auto poly with defaults of Jindak. Jindak and P3. We are done for the night. We have tested many things. We have fixed many things. And that is that. Thank you, everybody, for coming by. I'm going to chill and watch Choco Taco. Or maybe some ammunition making Legos. Actually, let's see if there's a programming thing to host. Right? Let's I mean, who could possibly be programming? Programming. When I look at game dev, it kind of sucks, honestly, but maybe we'll get lucky. So this is not game dev. This is just regular programming. NES emulator, but it's in JavaScript, so no. Talk show with Promisified. That's probably JavaScript. Everybody's JavaScript. What? Let's write an embedded OS. That could be cool. Let's host this guy. What do you guys think about hosting embedded OS? Right? I think that's an I and not an L. Embedded OS and JavaScript. All right. Thank you, everybody, for coming by. I'm now waiting a few seconds. We're supposedly in low latency mode, so I can just host, and here we go.